First question, what is the universe? If you knew a bit too much about physics, you might say that the universe is a set of events connected by a Friedmann-Robertson-Walker metric on large scales with zero curvature and a non-zero cosmological constant. But a wiser answer might be, I don't know. It's more of a philosophical question, really, than a scientific one. What is the universe? And that's okay. For our purposes, we can say that the universe is a bunch of stuff that happens, a set of events that occur in this place we occupy called space-time. It's a four-dimensional place, three spatial dimensions. We can move left, right, forward, back, up, and down in our three spatial dimensions. And we also move through time continuously. So that's our fourth dimension. We call it a temporal dimension. Four-dimensional space-time that we live in. And all events can be located by four coordinates. One coordinate with respect to each spatial axis and a coordinate with respect to the time axis. So where the event occurred and when the event occurred. Space extends in all directions infinitely. There is no edge to the universe as far as modern cosmology can determine. However, in time, we cannot go infinitely far back in time. The universe does have a very definite beginning. The Big Bang occurred about 13.8 billion years ago, so we can have a definite beginning to our time axis extending forward into the future. Space-time. So let's talk a bit more about locating events in time. If we want to know the relationship between events, it's useful to know how far apart in time they are and to do some simple calculations. Well, let's put some events on a timeline here. First off, the SI unit for time is the second, abbreviated S. So when we measure time always in seconds, convert all times to seconds. Use a lowercase t to represent time on our timeline in seconds there in parentheses, indicating the unit of our measurement on this line. We don't have to worry about the beginning of the universe here. We can pretend for our purposes that time extends infinitely far back in that direction. We do, however, need a reference point, a zero, a place where your clock says 0, reference point, RP. And let's make that, we can choose it to be noon on a given day. So we're setting our clocks to 0 at noon on that day. And this is a school day in which three interesting events occur. At time 1, T1, a chemistry teacher sets off the fire alarm. The school is evacuated. Let's say that occurs at about 1:09 p.m. A little later, a second event occurs, event 2, and the time on a clock at which event 2 occurs is 1:54 p.m. This is when a Spanish teacher is throwing the third class party for the week and sets a microwave on fire when trying to make popcorn. The school is evacuated again. The third event on this day occurs when some Project Lead the Way students set a motor on fire, again setting off the fire alarm in the school. School is evacuated for the third time at 2:47 p.m. Okay, three events, and T represents the time on a clock when they occur. We call it the clock time. Now, SI unit for time is seconds, so we need to get these times into seconds to be able to use them in calculations. So if T1 occurs at 1:09 p.m., we can write that as being 1 hour and 9/60ths of an hour after noon, after our reference point noon. So that first event occurs 1 and 9/60ths of an hour after our reference point. 9 divided by 60, we can convert this into a decimal. That's 1.15 hours. But we need to convert this into seconds. No problem. We know that there are 3,600 seconds in 1 hour. multiply by our conversion factor here. Hours cancels hours. 1.15 times 3600 in seconds gives us 4140 seconds. In other words, event 1, when the chemistry teacher sets off the fire alarm, that occurred 4,140 seconds after our reference point, noon. How did I know 3,600 seconds was our conversion factor? Because there are 60 minutes in an hour and 60 seconds in a minute, multiply these conversion factors together, minutes cancels minutes, and that tells us 60 times 60, 3,600 seconds in 1 hour. This is a conversion that comes up a lot, useful to memorize it. Okay, how about that second event, T2 at 1:54 p.m. In other words, 1 and 54/60ths of an hour after noon. Convert that to a decimal, 1.9 hours. To convert that to seconds, we multiply by our conversion factor. Hours cancels hours. There's 3,600 seconds in an hour. 1.9 times 3,600 tells us 6840 seconds after noon is when the Spanish teacher sets off the fire alarm. So let's mark these on here. Time T1 is 4140 seconds after noon. T2 is 6840 seconds after noon. All right, I'll leave you to figure out T3 in seconds. Next idea is time interval. That's the change in the time on a clock, and we represent it by this symbol, delta T. This triangle is the Greek letter delta, which we use very often. Delta means a change in something. So if I have delta of something, what that means is the final value of that thing minus the initial value of that thing. So delta T means the final value of the clock time, or the value of the clock time at the final event, minus the initial value of the clock time. The difference between the time on the clock between those two events. So for instance, if we want to find the change in clock time, the time interval, delta T, between events 1 and 2, in other words, how much time elapsed between events 1 and 2, we take the final time, T2, minus the initial time, T1. T2 was 6840 seconds after noon. T1 was 4140 seconds after noon. The difference between them, 2700 seconds. So that's our time interval. 2700 seconds elapsed between those two events. I want you to take a minute to work out the time interval between events 2 and 3. Go ahead and pause the video for a moment and work out how much time elapsed between events 2, when the Spanish teacher set off the fire alarm, and event 3, when the Project Lead the Way students set off the fire alarm. Got the answer? Okay, here it is to check.